Welcome back, everyone. This is Wylock's 6th grade worksheet for week 5, and I'm gonna just go over some problems with you guys to help you do the worksheet. And yeah, there we go. Let's get started. So, addition of integers. Find the sum. This is actually very simple. Um, at first, it can look really confusing because there's two symbols, but the best way you want to approach this, you want to treat minus signs as negative signs. So in this case, it would be 6 plus negative 12 plus 2, and this makes it a whole lot easier. So you can visually see that this is a different number than this one. It's not a difference of signs. So if you add everything up, it would be 8 plus negative 12. And if you're adding something into a negative number, you're basically just doing subtraction, right? Because this is the bigger number here. And yeah, so it would be 12 minus 8, which is 4, right? 12 minus 8 is 4. So it would be negative 4 because this is the bigger number. And if you just honestly, another one like this one right here, number 6, negative 9 plus negative 10 plus 10, or my bad, 19. So again, approach this as looking at a difference of negative numbers and positive numbers, not the difference of signs. So if you look at the question, it says negative 9 plus negative 10, so it's negative 19, right? And you add that to 19, these two will just cancel out, so it will just be 0. And yeah, that's pretty much it for addition of integers. It's a pretty simple concept. You want to just make sure you separate the number of numbers and by its positive and negative, not by its difference of signs directly. Alright, so moving on here, greatest common factor, very simple. You're looking for the greatest number that can fit into both of these, and it would still multiply out. So here, in this case, 15 and 5. Highest number here is 5, right? 5 times 1, so if I factor it out, here, it would be 5 and 3. And you can't really simplify for more here, or factor out more. So the answer is 5. That's the most common multiple that you have that is the same. And it's the same for all of these, honestly. It's pretty simple. Might take you a bit of time, but if you just factor everything out and look at the same, if you find a similar number, you should be good. Alright, moving on, least common multiple. Again, this is just pretty much the same thing, but instead of looking for the highest one, like this one, you're looking for the highest possible one. You're looking for the lowest possible one. So if I break it down here, okay, so this factors out into 3 and 3. Now this factors out into 5. Sorry, not 5. 6 and 3. Right? So if you look at the number here, then you can break this 6 down into 2 and 3. So if you look here, the least common multiple is 3. This is the least one. You're not looking for the most. I mean, in this situation, it wouldn't really matter, but you still want to break it down to the very end, just to see if you have any similarities. So you can see from here, it would be 3. That would be your answer. And realistically, I mean, I could just do that one over here. Let's see here, like this one, 13, 26. 13, you can only break down into 1 and 13. You can't really break this number down, right? It's a prime number. Now this one, it would be 2 and 13. So again, that's not the best example to show the least common multiple, but this is the only common multiple in this situation. That is technically the lowest in its form. You can't really factor out more from here, so it would be automatically 13. And yeah, that's pretty much it for least common multiples. It's not that difficult. Um, percentage word problem. Moving on here. We'll do a couple of these. Um, Emily has a packet of 40 M&Ms. 30% are red. How many M&Ms are not red? So in this problem, they give you the numbers of total M&Ms. This is total, which is 40. And they give you a percentage of a specific color. So red is 30%. So the way you want to approach this is telling you how much percentage of red there are. They're asking you for what's not red. So I'm going to just assume that they're trying to tell you that everything else is not red. So what I would do in this situation is remember how every single percentage or goes off, the highest is 100%. That's like the gold standard, right? It's like pretty much 1 and like 100%. It's like the highest number you could have in like an actual object, like a realistic scenario. Excuse me. So you can determine how 30% is red if everything else is not red, then you can just do this to eliminate the red portion, and it would be 70% of it would be not red. So going off this information, if all you gotta do is just solve it. So if it's 40 M&Ms, you can multiply that by 0.7. And this is because this is in decimal form and this is in fraction form. You have to bring the decimal back twice every time you want to translate that or convert that. And this, the answer for this, right, hang on, is 33.6. And this is a realistical problem. So you would want to make sure that you can only have whole numbers. So you don't want to round up because it's a realistic scenario. You can't have more than what you have, right? So it would just be 33. So it's pretty much easy. It's for all of these. I mean, they're pretty much the same thing. Like some of them just ask for the raw percentage, which isn't too bad. And they're just asking for different things. So yeah, that's pretty much it for this week. I hope you guys had a good week and stay safe, stay healthy, and I'll see you guys next week. Thank you for watching. Goodbye.